Hi guys, and welcome back to another video. So today we're given the problem, determine the moment of the force around point O. So to start off this problem, what we're first going to do is I'm going to break up this 300 Newton force right here into its x and y components. So let's start off with the y component. It's going to be moving upwards. So it's moving upwards, and then it's going to be using that 30-degree angle. It's going to be 300, and it's going to be a sine of 30 using our right angle identities. Next, let's move on to its x component. Now the x component is going to be a 300, and it's going to be a cosine of 30, and that's going to be the x component over 300 Newton force. So now that we found out both of the components of that 300 Newton force, let's move on to finding what the actual sum of the moments about point O is. So we're trying to find the sum of the moments about point O. I'm going to be using counterclockwise positive as usual. You can use clockwise positive, it'll end up as the same answer. And then that is going to be equal to a positive 300 sine of 30. Now this force, this 300 sine of 30, is going to be moving in the positive direction, because if you picture that force pulling that bar and the bar rotating, the bar is going to be rotating counterclockwise positive. So I'm going to make that positive, and then afterwards you just have to make sure that you're using the distance that's perpendicular to the force and multiplying it on. So that distance is, so if we picture this distance right here, this is the distance we're trying to find. This one right here. So this is actually going to be a 0.4 meters plus the 0.3 meters. However, it's at that 45-degree angle. So we're just going to adjust for that by multiplying a cosine of 45 meters. And then that is our distance that is perpendicular to that 300 sine of 30 that we're going to be multiplying on to find the moment. So it's 0.4 plus 3 cosine of 45. Next, let's move on to the next force. Now picture that 300 cosine of 30 force. Picture that rotating the bar. If you picture it correctly, it should be rotating the bar in a clockwise fashion. So that's going to be negative. So it's going to be a negative 300 cosine of 30. And then finally, we just need this distance right here. And that is going to be the 0.3 times the sine of 45 meters. And that is going to be the distance perpendicular to that part. So just multiply that on, 0.3 sine of 45. Now all you have to do is just plug in all these numbers into your calculator. You should be ending up, if you plug it in correctly, with a 36.72 Newton meters in the counterclockwise positive direction. And that is the final solution for this problem. Thank you all, and have a wonderful day.